Alright guys, I wanted to go over the quiz that you took a few weeks ago. I'm still working on grading them, but I wanted to go over it so as a review for your test the next couple days. So you guys can write these down and go from there. So let's look at 1A. Here, these are basic limit stuff for us to go over. First thing you always do is you do the substitution part. You're going to substitute the 1/2. So that becomes 3 times 1/2 squared times 2 times 1/2 minus 1. Before I get into 3 times 1/2 squared, I'm going to do the inside here. 2 times 1/2 is 1. 1 minus 1 is 0. 0 times anything is 0, so the answer is just 0. Done. Let's do the next one. Plug in 1. So 1 cubed plus 3 times 1 squared minus 2 times 1 minus 17. If this was the calculator part of your test, you could just plug it all in your calculator. If it wasn't, this is basic arithmetic, so you guys could just, figure all this stuff out and you'd be fine. And you would just get negative 15 as your answer. All right, here, plugging in negative 3. So negative 3 squared is 9. 4 times negative 3, so it's minus 12 plus 3 on the top. Over, again, negative 3 squared is 9. 9 minus 3 is 6. So here I get 9 minus 12 is negative 3 plus 3. That's going to be 0 over 6. You cannot leave 0 over 6. 0 divided by 6 is 0. So your answer is 0. Part D, now plug in 0 here. Well, here, you're going to get, if I plug in 0 in front of the x's, 0 over 0. That's the indeterminate where you have to do more work. So that means you actually physically have to do more work. Options. If this is the calculator part, you can just plug this in your calculator. Make sure you use parentheses for the top and the bottom. And then get really, really close to 0, like 0.00001, 0.00001, whatever. Keep going like that way and see what it gets really, really close to. Another thing, if this was the non-calculator part, is I could factor this out algebraically. So I still have the limit as x approaches 0, and I noticed that I have an x squared, at least in everything, so that becomes 5x plus 8 on the top over, again, x squared. I can take out, and that becomes 3x squared minus 16. The x squares cancel out. I plug in 0. This is 0 plus 8 is 8 over negative 16 or negative 1/2. You are in AP Calc. You are expected to reduce fractions. Here, plug in negative 3. So it's going to be negative 6 times negative 3 squared plus 5 times negative 3 plus 12. So again, you guys can just do the arithmetic, or if this was the calculator part, plug it into your calculator. If you do that, you get negative 57. F, plug in 2. So 2 squared is 4. 4 minus 4 is 0. 2 minus 2 is 0. So again, this is an indeterminate, so you must do more work. So actually do the more work. Do not write more work as your answer. Do the more work. Again, if this was the calculator part, you would just graph it. Non-calculator, I can factor it. X squared minus 4, if I undo FOIL, I keep this, the limit as x approaches 2. If I undo FOIL, that becomes x plus 2 times x minus 2. The denominator is still x minus 2, but look at that. I've got x minus 2 in both the numerator and denominator. That cancels out, so then plug in 2. 2 plus 2 is 4. All right, G. Thing. Plug in infinity. This is all still infinity over infinity. Infinity over infinity is also an indeterminate. But here's the other thing you guys have to remember, is that if I'm taking the limit as x approaches infinity, I'm actually finding the horizontal asymptote. And I gave you guys a shortcut for this. We said we look at the exponents. here, the exponents are the same. So if the exponents are the same, I'm just going to look at the coefficients. So that's going to be 5 over 10, which becomes also a half because it reduces. So that means I have a horizontal asymptote of a half. Again, this only works if the limit of x is approaching infinity. So there will be these limit type questions on your test on both the calculator and the non-calculator part. So make sure you guys know how to do that. These limits is another thing that you guys are going to get something in a graph that you're going to do a bunch of limits from the graph. So limit as x approaches 2 from the left. So here's 2 over here. So as I'm approaching 2 from the left, it's getting closer to 0. The y is getting closer to 0. Limit as x approaches 2 from the right, also 0. So the limit as x approaches 2, because the limit's the same from the left and the right, it equals 0. F of 2 is 0. Now, to add on to 2.3, this is part of 2.3, I could say that this is continuous at x equals 2 because these two are the same. Got it? Let's look at x approaches negative 1. So there's negative 1. As I'm approaching negative 1 from the left, my y is getting closer to negative 1. As I'm approaching negative 1 from the right, it's getting closer to negative 3. Limit as x approaches negative 1. Well, they're different from the left and the right, so that means it does not exist. And what is f of negative 1? F of negative 1 is negative 3. That's where the closed circle is. You have a discontinuity. Because those two are different. That is a discontinuity. And because these two are different, it's actually a jump discontinuity. It looks like the graph, and then it jumps to a totally different graph. It goes from a line to a parabola. So there will be discontinuities on the graph, on the test, as well as doing limits from a graph. 3, find the vertical and horizontal asymptotes of the graph. All right, so first off, if I was going to do the vertical asymptote, you just take the denominator and set it equal to 0. So that means you're just going to do x squared minus 16 equals 0. Add 16, x squared equals 16. Take the square root. When you take the square root, you need to remember it is a positive and a negative, so there's actually 2 vertical asymptotes there, one at positive 4, one at negative 4. Horizontal asymptote, that's just like how we did the last question on number 1 on the first page. We look at the exponents. Here, the exponent of x is just 1. This is a 2. So that means the denominator is bigger. That means your horizontal asymptote is going to occur at y equals 0. That was that shortcut. All right. Using a piecewise function to answer the question. I know how much you guys all love piecewise functions. So here we go. I've got this function where the function is 1 over x minus 1 when x is less than 1, and x cubed minus 2x plus 5 when x is greater than or equal to 1. So that means I've got the splits happening at 1. This is to the left of 1. Here the x's are all bigger than 1, so this is to the right of 1. So when it's asking for the limit as x approaches 1 from the left, that means I'm using the top one, where I'm going to plug it in. So 1 over 1 minus 1, that becomes 1 over 0. Now we've discussed this before, I believe. Remember, the denominator is approaching 0. I can't actually divide by 0. You guys learned that back in 3rd grade when you first learned division. I can't actually divide by 0. Got it? But I'm getting closer to 0 in the denominator. If my denominator is getting smaller, my fraction's getting bigger. Half a piece of pie is bigger than a quarter of a piece of pie, right? So as my denominator gets infinitely smaller, my fraction gets infinitely bigger. This is actually going towards infinity. So what happens here? If my denominator equals 0, that means you had a vertical asymptote is technically what's happening at this spot. Now the limit as x approaches 1 from the right. That means I'm going to plug it into the other one. that's going to be 1 cubed minus 2 times 1 plus 5. That's going to be 1 plus 2 is 3, 3 plus 5 is 8. Straightforward. Limit as x approaches 1. Well, same thing. It's different from the left and the right, so it does not exist. It don't have a limit there. F of 1, well, this is the one that has the or equal to, because that means that's when it equals 1, so I'm going to use that one, which we already know is 8. And there you go. All right, this last question always seems to get people. This is pretty much how the AP Calc test could test you on vocabulary and limits. Do you understand what it's asking? For example, if I'm taking the limit as x approaches infinity, or negative infinity, what's happening is the horizontal asymptote. Do you understand that it's telling you have a horizontal asymptote? I have a horizontal asymptote at y equals 2. So that means I'm going to put a horizontal asymptote at y equals 2 here. Limit as x approaches numbers and they equal infinity or negative infinity, that means you have a vertical asymptote. So that means at negative 2, I'm going to have a vertical asymptote. Got it? And now look at what it says here. From the right, it's going towards positive infinity. So I can't be below this one. I have to be up here. Different color. Here, from the left, it's going towards negative infinity. So that means it's got to come down there. And the last thing it says is that the limit as f of x as a limit as x approaches 4 of f of x equals f of 4, that's a continuity. That means they're the same thing. So at 4, 1, 2, 3, 4, I have a closed circle there. You don't even have to draw the closed circle. You're just showing that there is no discontinuity. This is an example of what this graph could have been. Here it's testing you, do you understand your vertical and horizontal asymptotes? So, your tests will have the limits. You have to do it graphically, algebraically, do it with a calculator, without a calculator, all of that. It will have discontinuities. The ones you really need to know are the infinite, which is just your vertical asymptotes, jump, removable. You need to know your asymptotes. Horizontal, that's where you have to take the limit as x approaches infinity, and you look at the degrees. And the vertical, where you set your denominator equal to 0. There will be one question also on your instantaneous rate of change. That was 2.4. You might want to look at that video again. Was the limit as h approaches 0 of f of a plus h minus f of a all over h. One question on that. Rest of it's going to be mostly on the basis of limits. So that is your test. Study. Good luck. You guys will then be doing some parts of chapter 3, and then I will be back in 3 weeks. Bye.